Fire investigation is going to be a quick topic, quick turnaround here. Arson investigations are difficult to carry out because it's a thoroughly planned event. The perpetrator is not present during the act, and oftentimes the destruction is incredibly extensive. So an investigator's function is to detect and identify chemicals collected at the scene, and then obviously reconstructing the scene and identifying igniter mechanisms. Fire is a type of oxidation, which is the combination of oxygen with other substances to produce new substances. This is an exciting sort of oxidation. Rusting is another form of oxidation. The minimum temperature needed to get a fuel to burn is called ignition temperature. That's what has to be reached in order for a fire to start. Fuel, like wood or paper, they don't just spontaneously burst into flames. You need to get that fuel to an ignition temperature. The heat that comes out when a substance burns is called heat of combustion. A liquid burns when its temperature is high enough to vaporize it. That's called the flash point. A solid has to be hot enough to decompose into gas. That's called pyrolysis. Glowing combustion or smoldering is burning at the fuel-air boundary, like a cigarette. Spontaneous combustion is a rare event, but that's where you have a natural heat-producing process in poorly ventilated containers or areas. And so that gets the heat high enough for the material to ignite. There are three things that are necessary for the combustion of fire, for a fire in order to be sustained. So fuel, oxygen, and heat. And this is called the fire triangle. Fuel, oxygen, and heat. First thing that needs to happen when an arson investigator arrives on the scene is the fire scene has to be searched for signs of arson. Most arsons are started with petroleum-based accelerants like gasoline or kerosene, and those have a quick evaporation time. So investigation has to begin immediately so that that accelerant, if it's there, doesn't get missed because it's evaporated. The main objective for in searching a fire scene is coming up with where the fire started or its origin. And that's where you're figuring out, is there an accelerant? Was there an ignition device that was used? Abnormal fire observations can also be caused by stairways or elevator shafts, winds or drafts, collapsing of floors or roofs, and holes in the structure. Any one of these can cause fire to burn uncharacteristically and cause some strange patterns. Some telltale signs of arson, so deliberately set fires, include evidence of separate and unconnected fires. So someone has started a fire in multiple places in a building. Use of streamers to spread the fire from one area to another. Evidence of severe burning found on the floor as opposed to the ceiling of a structure. And this would be due to a flammable liquid. Under normal circumstances, a fire burns up. So the origin, if it's deliberately set fire or an arson, will be the lowest point, showing the most intense characteristics of burning, because liquid runs to the lowest point. Liquid of a petroleum product that's been used to start the fire runs to the lowest point, and the burning is most intense there. Combustible liquids are rarely entirely consumed during a fire. That's why the search goes on for accelerants. At the point of origin, once it's been determined, ash and soot and then porous materials that might have accelerant in it should be collected. Those are stored in airtight containers to prevent evaporation, and then there's an airspace to remove samples for analysis. At the scene, traces of liquid residues can be located with a machine, a portable vapor detector, or a sniffer, and then trained dogs can also do that job. It's also important that uncontaminated control specimens be collected and analyzed as well, along with the suspected material that contains an accelerant. A search for igniters like matches, a sparking device, or parts of a Molotov cocktail may help also with determining whether the fire was accidental or arson. Again, when a fire occurs, oxygen, an oxidation reaction is what it is, and the oxygen combining with a fuel produces large amounts of heat and light, like flames. So again, we have to have a fuel source, oxygen, and heat. The fire triangle in review. When you have a situation called flashover, this is what would completely and very quickly destroy a structure. So this is a near simultaneous ignition. So all at the same time, most of the combustible material, most of the fuel in an area gets hot enough all at the same time to combust all at once. And then that area is very quickly destroyed. Now, in terms of analysis, this is going back to drug analysis, that topic. We're going back to the gas chromatograph. It's the best way to identify drugs and also accelerants in flammable residues. Attaching that gas chromatogram to a mass spectrometer gives us more thorough analysis, more of a unique identification. And again, just to review, vast majority of arsons are petroleum products like gasoline and kerosene. So those are the accelerants that are used. The gas chromatograph, remember, separates the hydrocarbon components, the compounds, and produces a pattern that's characteristic of a petroleum product, whether it's gasoline or kerosene or another kind. Then analysts compare the gas chromatograph peaks from the fire scene debris to known standard reference samples, flammable liquids. You might be able to identify that accelerant used to initiate the fire.